Hi, welcome to video lecture 16. My name is Fatih Kırshanlı and this week we are going to talk about the firm and its customers. In this video lecture, I am going to be covering chapters 7.0 through 7.7. As we all know, the US economy is dominated by large firms, and large firms exist due to economies of scale or increasing returns. And these firms are typically price setters. In the price-setting situation, firms pursue a variety of strategies to maximize their profits. For example, they innovate products or processes, they advertise and market. In other words, they do advertising and marketing. They can do political lobbying, they can do weight setting, they can do price setting. In Unit 7, the studies that we are going to be talking about covers that these firms sell differentiated goods. They have some market power, some firms set low prices, and some set high prices. On the other hand, in Unit 8, we'll study price-taking firms. In a price-taking firm situation, these firms sell homogeneous goods. They have no market power, and they all sell at the market equilibrium price. Is your employer's product differentiated? In that regard, we can think about Apple Cinnamon Cheerios. Is it different from what other firms sell? If your firm raised its price, would it still sell some product? We can think about all these questions. What about choosing the prices? So, as you can see in this demand curve, we are actually seeing consumer demand. Here, when price is equal to $4, the pounds of Cheerios are produced as 16,000 pounds. When the price is equal to 3, there are 24,000 pounds. When the price is equal to 2, we have 36,000 pounds. And these also show the consumer's willingness to pay. And as you all know, downward sloping demand curves fit the law of demand. Now here, like choosing a price, we have like a firm's profit also depends on its cost. And suppose that the a unit cost of Cheerios is $2 per pound. So total revenue is equal to R times price times quantity, and total cost, since we already found the price and we already decided about the price, which is $2, total cost is going to be 2 times quantity. And profit is going to be pi minus total revenue minus total cost. So, or in other words, P times Q minus 2Q. And here, each curve corresponds to isoprofit curve. An isoprofit curve shows combinations of price and quantity that lead to the same level of profit. And then here, the firm maximizes its profits subject to demand for its product. In this feasible set, in our case, let's think about this is our feasible set, and point E is the highest feasible isoprofit curve when price equal to 4.40, quantity is equal to 14,000, and then our total revenue corresponds to 61,600, and the cost is equal to $28,000, and the profit is going to be $33,600 or $34,000. So, and then point E, we know that MRS equal to MRT. In these like isoprofit curves, the firm could calculate its profit for every price on the demand curve. For example, when the like price equals to like 600, $6 $75, profit is going to be around $10,000, and then all the way down when the price equals to $2, profit is going to be zero. So why not then then since we already found the highest profit $34,000 when the price equals to 4D, or does like firm really choose prices this way? Economies of scale. As I talk about economies of scale at the beginning of this video lecture also, they play a critical role for profit maximizing. So large price setting firms like Walmart, Toyota, and Amazon exist largely due to economies of scale or increasing returns. Economies of scale result from technological advantages when large scale production requires fewer inputs per unit of output. And also, economies of scale result from cost advantages when large firms purchase inputs at lower costs. And also, they result from network economies when people purchase a good because it has many consumers or users. So, at the end, industries dominated by small firms generally have constant return to scale or decreasing returns to scale. Now, let's go and then talk about technological advantages, which was one of the results of economies of scale. And then here, if you in the first graph, you're seeing, or first picture, you're seeing doubling the diameter and circumference of a pipe quadruples its area and flow, and that might actually increase the profit. Or rawhide energy station converts coal into energy more efficiently than you. Um, so what about cost advantages of the economies of scale? If like here you can see in Walmart, for example, they have cost advantages because when they actually buy some, let's say, products, they can actually get them with lower costs than many other small firms. And network economies work kind of likewise. And in market capitalization in fall 2019, Apple had $1.09 trillion dollars, and Facebook had around like $542 billion dollars market capitalization. And then we can be sure that now these actually capitalization numbers are much higher, especially for Amazon after the pandemic. So we have talked about economies of scale, but what about these economies of scale? And then logically, you can kind of have an idea about what it means, and then you can actually get into um, an understanding of this concept from your textbook also. And then here, I wanted to share like kind of funny caricature that you can see how it works. So increasing the workforce tenfold increases production employees less than tenfold. And if people can only supervise 10 workers, a firm with 10, whatever the like 10 over 2, 3 production workers will have X levels of management. And then setting the price of beautiful cars, for example, in Chevrolet, in this case, this firm has both economies of scale and diseconomies of scale. And here we are going to talk about cost curves. The one above, you're seeing the figure on the right hand side, the one on above which corresponds to total cost of production, the one which is below shows the average cost. So the cost of producing any quantity of cars is given by the function C equals to CQ, and the average cost of is given by the function AC equals to total cost divided by quantity. When Q is 0, we cannot find the average cost, but here we are seeing F, the cost still like $48,000, which is the fixed cost. And then when Q is 20, we are having cost is 80,000, AC is 4,000, and when Q is 40, cost is $136,000, and then average cost is $3,400. And when Q is equal to 60, our cost is $216,000, and the average cost is $3,600. And then the points A, B, and D in the below part is showing the average costs for 20, 40, and 60 quantities respectively. Now with the cost curves, we are going to work on the marginal cost. And the marginal cost is given by the equation MC dC over dQ. Or in other words, we are taking the derivative of the cost function with respect to quantity. And also marginal cost is showing the differences of cost divided by differences of quantity. So when Q is 20, our marginal cost is around like 2,200, and when Q is 40, marginal cost is around like 3,400, and when quantity is 60, our marginal cost is around like $4,600. And then here you're seeing points A, B, D on the figure below, which actually shows us the marginal costs for 20, 40, and 60 quantities respectively. So when it comes to our interpretation, what we can say, when our marginal cost is less than our average cost, then average cost declines with quantity, and we are having economies of scale here. When marginal cost is bigger than average cost, we are having average cost increases with quantity, and we are going to have diseconomies of scale. So when we talk about demand for beautiful cars, if you remember in one of the previous slides that I was talking about, deciding about the price of beautiful cars, like these firms actually are having both economies of scale and diseconomies of scale together. So cars are differentiated products because each make and model is unique. And there are 100 potential customers of beautiful cars. Demand is given by the equation, as you can see in the right hand side. Willingness to pay 8,000 minus 80 times Q. Why we are having this willingness to pay equation? Because our willingness to pay is like in the demand curve, we are having the maximum is 8,000, and then 80 is the one that we are having 8,000 divided by 100, we are having 80, excuse me, and then 8,000 minus 80 times Q makes our total willingness to pay. Okay. For example, if Q is equal to 60, willingness to pay equals to 3,200. And then when so if P is equal to 3,200, Q is equal to 60. So you can go the other way around because our willingness to pay equals to basically price, right? This demand curve is linear for simplicity. Okay. What about setting the price of beautiful cars, as I was talking about at in one of the earlier slides? So profit is given by the equation like pi equals to total revenue minus total cost, as I mentioned before, which can also be written as P times Q minus CQ. or Q P minus AC. So capitalists earn abnormal profit even when P equals to AC and profit is equal to 0, as you can see. Here, P Q times P minus AC is equal to around like $30,000. So profits are maximized when MRS equal to MRT, and then here we are seeing that point as C. P equals to 5,440, and then quantity is equal to 32 in that point where profits are maximized. And here profit is equal to 63,360. And then this is the area of profit. How we are finding it? It's pretty simple. So when MRT equal to MRS, which is our C here, we already know the corresponding price and quantity. We are going to go all the way down to our average cost curve and then finish the length of or the height of rectangular there, and then shape the rectangular this way and then calculate the area like that. And then here we are seeing like $63,000, like 63,360 profits when the profits are maximized. And then here we are seeing with the blue rectangular the same logic, going all the way down to average cost and then shaping the rectangular. Our profit was $30,000. So we talked about like price setting with price, and now we are going to set the price using marginal revenue. So a firm's marginal revenue is the change in revenue from increasing the quantity from Q to Q plus 1. And the marginal revenue equals to extra revenue from selling one more unit minus the lost revenue from decreasing the price for all units. And then here, when quantity is equal to 20, our price is equal to 6,400 and the revenue is equal to 128,000. When the quantity is 21, then price is going to be 6,320 and revenue is going to be equal to 132,720. And then since the change between like 21 to 20, our change in quantity is 1 and change in price is $80, basically minus $80, and revenue is 4,720 more in the latter case than the former. So gain in revenue is equal to 6,320. Loss total cost is going to be like total cost in all the other cars, 20 times minus 80, which is equal to minus 1,600. And then the marginal revenue is going to be the difference between these two. So gain in revenue minus lost in revenue, which is going to make our marginal revenue equals to 4,720. So marginal revenue from selling the 11th unit in this, according to this example in the figures like right hand side, 11th unit like the marginal revenue that we are getting from the 11th unit selling is 6,320. 21st unit 400, 720. 41st unit 1,520. And 61st unit is minus 1,680. So this is like points A, B, D, and E corresponds to our marginal costs in this demand curve. So basically 11th, 31st, 41st, and 61st units are corresponding to A, B, D, and E in the graphs. So marginally, like willingness to pay, in other words, price, 8,000 minus 80 times Q, which can be written also like this and according like that. And then from here, marginal revenue is going to be um, derivative of total revenue with respect to Q, which is equal to 8,000 minus 160 Q. And profit maximization is at MR equals to MC, which is equal to point C here. And from here, we can say firms should sell if their marginal revenue is bigger than their marginal cost, and they shouldn't if the opposite. And then for that, you can study like MR, marginal revenue, marginal cost, and profit from Unit 7. So now again we are talking about like setting the price for beautiful cars, and then the firm will choose a price and quantity that um, um, reaches its highest feasible isoprofit curve and equates marginal revenue with marginal cost. And here you're seeing marginal revenue curve. Price setting firms will choose an inefficient price. It doesn't exhaust all gains from trade. As you can see, when it doesn't exhaust all the gains from trade, that triangle happens, and that triangle gives us deadweight loss from that trade. For example, like 18 potential consumers are willing to pay more than the firm's marginal cost in this example, because 50 minus 32 equals to 18. Now let's go and talk about gains from trade. When economic interactions are voluntary, they generally benefit both people. So in this interaction, the firm sets the price, consumers decide whether to buy, and the total surplus measures the total gains from trade. So we can analyze the size and distribution of surplus in terms of Pareto efficiency, fairness. Okay, in this example, red line curve corresponds to our demand curve, yellow marginal cost, and blue is the isoprofit. There are potential gains from trade whenever the firm can produce a car for less than a consumer is willing to pay. A consumer enjoys consumer surplus when their willingness to pay is bigger than the price. For example, here the 10th sale is going to give 1,760, and 15th sale is going to provide like 1,360, and a consumer surplus is going to be the entire triangle here. And then if you remember from the calculus classes how to calculate the area of a triangle, your consumer surplus is going to be 40,960. So, and here a firm, on the other hand, enjoys the producer surplus when MC is less than the price. If you remember from the consumer's perspective, when their willingness to pay is bigger than the price, they enjoy the surplus. In the firm's perspective, they enjoy the surplus when their marginal cost is less than the actual price. Here, 20th sale, sorry, 20th sale is going to give like 3,540. 32nd sale is going to provide like 2,520, and then the producer surplus is going to be the entire yellow area, and you can do this calculation by yourself and then end up with the the producer surplus 111,360. And profit is going to be the difference between the producer surplus and the fixed cost. And if you remember, our fixed cost when the quantity was zero was equal to $48,000. When we deduct this amount from the total surplus, our profit is going to be 63,360. And the total surplus is going to be the consumer surplus plus the producer surplus. Basically, the red triangle plus the yellow trapezoid is going to make our total surplus 152,320. And a price of 5,440 doesn't maximize the surplus. So suppose the firm sold cars to another 18 consumers for $4,000 each. 18 consumers are better off. The firm is better off, um, and the gains from trade are larger. So then why not like simply charge everyone $4,000? Because setting the price at $4,000 would maximize the total. Um, Setting the price at like $4,000 would maximize the total surplus, but not the firm's profit. And if the firm charges all consumers the same price, it will sell the price at like 5,440, and fail to realize these potential gains of trade. And this is going to make our deadweight loss um, like 18, which is like 18, like the quantity, which is the difference between 50, 32. And then when we make this calculation here, our like deadweight loss total is going to be this area, and then with the MR is here. So you can calculate the deadweight loss and then find it around like 22,680.